So let's take pong, for example. We want to know, is the circle inside the rectangle? That might be kind of a tricky thing to solve for. So let's start with an even simpler shape than a circle. Let's just start with a single point, a single set of xy coordinates. And we'll try and write some code that figures out, are one set of xy coordinates inside a rectangular region? It's often easier to think of coding with a small example for yourself. So let's imagine just a random rectangular region, as I've shown here. And we want to test if a single set of xy coordinates is inside the rectangle. So let's use mouse x, mouse y as our xy coordinates. So we're going to try and write if statements that ask the question, are these two coordinates inside the rectangle or outside the rectangle? So let's break that into two different parts. First, let's ask if the point is in the horizontally correct position. So is it between the left boundary and the right boundary? And to make this simpler for ourselves, let's go ahead and draw in the boundaries so that we can think clearly about the question. So I know the coordinate of the left boundary is the same as this coordinate, which is 450. So I'm going to mark that. Where's the right boundary? Go ahead and pause the video and think about it for yourself. So here, the left boundary is at 450. I know the width is 150. So the right boundary must be at, let's see, 450 plus 100 is 550, plus another 50 is 600. So now I've got the two coordinates of the left and right hand boundary. So to test if my particular x coordinate is between the left boundary and the right boundary, what I really want to do is test if mouse x is larger than 450 and smaller than 600. So you could translate it into code this way. Here I'm asking, is it true that mouse x is larger than 450 and also mouse x is smaller than 600? So think about the logic of how we're putting this idea together. We're starting with an idea. Is a point inside a rectangle? And we're breaking that question down into smaller questions that are about numbers. So we're saying, is the x coordinate between the left x coordinate and the right x coordinate? And then once we've made our human question into a question about numbers, now we can rewrite it in code by taking the x coordinate we care about and asking if it's larger than a small x coordinate and also bigger than a large, backwards. If it's bigger than a small x coordinate and also smaller than a large x coordinate. Is it between the two boundaries? So let's do that same thing for the y coordinates now. And why don't you try to do this whole thing all by yourself? So imagine, where are the two vertical positions? We want to know, is our y coordinate between the top and the bottom of the rectangular region? See if you can type that as an if statement. So I want to test if my y coordinate is between the top and the bottom. I see that the top coordinate is 200. I see that the height of the rectangle is 100. So the bottom coordinate must be 300. So if I wanted to rewrite this in code, I want to ask, is the y coordinate of the mouse larger than 200? Because that would mean it's below this top boundary. And also, is the y coordinate smaller than 300? Because smaller than 300 means it's above the bottom boundary. So I've tested, is it on this side of the 450 line? Is it on this side of the 600 line? Is it on this side of the 200 line? And is it on this side of the 300 line? And if all four of those things are true at once, then I know the mouse must be in the middle. And it doesn't have to be the mouse coordinate. Imagine that we wanted to test if a ball was inside the rectangular region. The ball wouldn't be at mouse x, mouse y. The ball might be at bx, by for ball x, ball y. In that case, you just change the x coordinate that you're testing. So instead of testing mouse x, you test the ball x coordinate. And instead of testing the mouse y coordinate, you test the ball y coordinate. So the patterns are the thing that you want to focus on. You want to ask, what numbers do I want to ask questions about, and what are the questions that I want to ask? So let's use that same idea to figure out if the ball is hitting the paddle. Instead of asking, is the entire circle overlapping the paddle, I'm just going to select one point. I'm going to select the point right at the bottom of the ball. And I'm going to ask the question, is this point inside the rectangular region? And if the answer is yes, then I'll assume that the entire ball is touching the rectangular region and that we should make it bounce. So just like last time, I want to test if the ball x coordinate is between the left and right hand side of the paddle. So let's draw on our boundaries so that we can think about it clearly. And then I also want to know, is the bottom y coordinate of the ball below the top of the paddle? So in other words, I want to test if this point is anywhere inside the shaded region, because if this point is inside the shaded region, I know that we're going to try and bounce. Okay, what makes this a little bit trickier than last time is all of these things are moving. The ellipse is moving and the paddle is also moving. So the left-hand boundary isn't a number like 200. It's going to be a variable like px for paddle x. But that's the whole magic of algebra, is px is just a number. You don't have to know what number it is to treat it like a number. So let's go ahead and write our boundaries. Here the left-hand boundary is px. The right-hand boundary must be px plus the width of the paddle, plus 200. So this is px plus 200. The top boundary here is just py. And I'm actually not testing to see the bottom boundary. Maybe we want to, but I'm not going to. So we just need to test if the bottom coordinate of the ball is below the py boundary. So what is the bottom coordinate of the ball? You can see here my ellipse statement, the height of the ball is 60. So that means the radius of the ball must be 30. So if this center ball coordinate is by, then the bottom of the ball must be by plus 30, because I'm adding 30 more pixels to get from the middle to the bottom. So if we're going to translate it all into code, I want to test if the ball x coordinate, which is bx, is larger than this left-hand side, which is paddle x. So I'm saying, is the ball x bigger than the paddle x? And also, is the ball x smaller than the right-hand side of the paddle, which is paddle x plus 200? So it looks very obscure, but it's a very natural question. It's just like last time. I'm asking, is this particular x coordinate between two others? And then for the y coordinate, I'm not testing ball y, I'm testing this coordinate. I'm testing ball y plus 300, because that's the point that I want to know. Where is it? So I'm going to ask, is ball y plus 300, is ball y plus 30, is it below this top boundary? So is it greater than the paddle y? And that's all. And if all three of those are true at once, I know that bottom point of the ball is inside this region, and I can make it bounce. Just a quick note on the bouncing. If the ball was traveling this direction, let's think about where it's going. It's moving left and down before the bounce, and then after the bounce, it's moving left and up. So it only actually changed one direction. It was moving left before the bounce, and after the bounce, it's still moving left. So we wouldn't actually want to change its horizontal direction. We wanted to keep traveling in the same horizontal direction. But look, the vertical direction changes. Before the bounce, it's traveling down. After the bounce, it's traveling up. So you can think, what would you need to do in here to have it bounce in only the way that you want it to bounce?